go ahead and create an Atlas cluster using a free tier so that you can do some testing in place with us here. There was a link, let me show it here. In the document, we'll go ahead and bring it up. I've already kind of walked through the first click-through screen here. I'm going to use my Google, again, a kind of a dummy Google account here. That's probably the simplest way with an SSO, but feel free, if you don't want to use a Google, you can walk through and kind of create your own profile there and put in a different email address. If you haven't done this before, again, it's going to kind of ask you to come in and create an organization. Go ahead and just do that real quick. We want to use Atlas here, and we'll call it JSLA test. By default, it'll pick your user and give you permissions, but of course you can create and add other users into the project. Really, the projects help define a number of things, as we'll point out here. Certainly, user level access and roles and permissions are all set at the project level. So, we can come in and create, again, role-based access on these free tiers. We're going to just set up some Scram users or just basic username and password logins. But there are, as you move into enterprise, there are a lot of other capabilities like setting up LDAP, even working with AWS IAM as an authentication method, and using AWS IAM roles as well for an organization. So I'll show that set up in a different cluster here, but I should look very similar. Okay, let's go ahead and create a project. And once you of data, and of course, limited connectivity options and connections. But it should be plenty for tonight. Just go ahead and click through and say, create cluster. That should take a few minutes. But feel free to go ahead and do that. I'm gonna, while that's running for you folks, let me go ahead and bring up an actual production cluster here that I've got set up. Okay.
And Aaron, it looks like if we have time, there's some interest in seeing the AWS IAM setup if you have time towards the end possible, and then I'll Lambda with AWS and Mongo.
Okay, yeah, absolutely. I can actually do that now so this is my production cluster. As you see, we have a lot of different projects set up in here. Some of these are using simple free clusters just for testing in place, like I showed, but some are, using for potentially production or customer scenarios that might have different setups. But I'll show you mine because I know I have AWS set up in here. And luckily, Aaron is top of the list. We'll give it a minute. Let me go ahead and resume this cluster. We do have ours set to sleep past 6 p.m. So that's why you're seeing that thing go offline. But on your left-hand side is really where you have a lot of the admin capabilities for the individual projects and clusters. So we'll start with network. Let me start with network access. Oops, click too many things there. Network access. So here on your cluster, you'd want to come in and go ahead and add an IP. You can either set it wide open, allow really anyone to connect as long as they have a username and password, or you can identify, as you can see, I've allowed my individual IP or /32 for this subnet here. I'm on Cox network at home. And so I've gone ahead and predefined roles for you within Atlas, but you can absolutely come in and kind of create your own roles and limit things down to even a collection level and whether or not it's read or write. Like I said, maybe you want to read only or a write only, and both those scenarios are obviously supported and valid. But also kind of cluster administration capabilities, the project management capabilities are all different roles that you can set in here. So again, lots predefined, but absolutely also allowing you to kind of define your own. A little echo there. What I'm showing here is if others on AWS, I've set up a few different demos over time. This is using an AWS VPC, so again, allowing connectivity over their peering network. In this case, to US West 1, so the clusters in West 2, just to show what that looks like. And then more recently, we've added private endpoint support as well. So in this case, it's directly to a host in US West 2. I'll just show you what that looks like real quickly. You can come in again, select the provider, decide which region you're connecting to. Let's use West 1. And then, of course, this would be your AWS config for those VPCs and subnets that you're trying to create access to. So this is kind of the Atlas side of the config. There's obviously some other AWS side that needs to be pre-existing to allow this all to connect. But again, very simple and easy way to kind of click through, add your VPCs, add your subnets as needed. There's some good documentation around this too, in terms of what's required on the AWS side and potentially, setting up load balancing and or peering. Go ahead and delete that out. But back to the user access as well. So you can see I've here at Mongo, we use IAM for really all our access. And so this is my actual role that was created, but it's fairly simple. There is a requirement on the cluster itself to be of level 4.4 or higher. 5.0 is coming out soon. 4.4 is our GA. And this was added in the 4.4 release. But you can see here, you can come in and define a user or a role, and then simply supply the ARN. And then you can also, again, select an individual role that may have already been created or that you're creating yourself to decide actually what the kind of access levels that user will have on any given database within this project.
And Aaron, one more question that came through. Is it best practice to use peering and private endpoints when working with AWS, for example, with Lambda?
Yes, peering in particular. Private, there's some additional charges for, but with peering, it's basically going to be the most efficient. So you're running over a peer network internally instead of using the public interfaces, which are charged at a different rate. So absolutely, if you're hosting application servers within AWS, I would highly recommend to connect over that peering network. It's going to be the most efficient and potentially the safest. Certainly prevent you from going for the open internet access. But for tonight, for those clusters, for those of you that haven't set it up yet, feel free to come in and create a user. It's, again, very simple to come in and create, identify username and password. And in this case, you can just create it as an Atlas admin and just do test.js so you can see it. Or you can auto-generate a password. We'll go ahead and create a user. You'll see now that we've added this, and those changes will be applied to all the clusters. So this is kind of the beauty of the Atlas system in itself, in that all that configuration automation is kind of built for you. So as you can see here, I'm pointing clicking through UI. I'll just point out all of the functions that this is built on are available for developers, so you can code to our Atlas APIs to do everything that I'm showing here: create a cluster, create a user, create a peering endpoint, all of those things. Also supported on Terraform or AWS Cloud Foundry directly as well. So lots of ways to programmatically kind of deploy and support these infrastructure and environments as well. Okay, any other questions on the user, how you set up the user? Hopefully we're all kind of caught up there. If there aren't, I'll just point out there are a few other key configurations. Again, as you move into a enterprise level agreement with Mongo, this allows for things like enabling LDAP authentication with your current enterprise configurations. Another really important feature that we've added is allowing users to manage their own keys, of course, using AWS, KMS, or maybe it's Google or Azure, depending on your deployment strategy there and your cloud strategy. But this will allow you to apply your own keys for encryption at rest. I'll point out that we also do allow field level encryption, which is another new feature for Mongo, and that allows developers to encrypt from the application side and actually pick specific attributes within even a collection to encrypt prior to being loaded into the database. So now you're truly, again, encrypting at the field, as we call it, or at the client side. So even as it's stored in Atlas, it's been encrypted. So those features are part of the, again, the kind of enterprise support, but as you can see, they're very simply managed here. Of course, database auditing as well, all kind of enterprise level features. Great. Okay, so, but once you have your cluster configured, set up, hopefully a user, it's pretty easy to come in and load a sample data set. And we'll be leveraging some of that data set as we go through today. So for those folks that don't have an existing cluster, or maybe did have an existing cluster, please feel free. It's a small data set, and we can drop it out later tonight after the testing. But feel free to go ahead and load that data sample set up just by clicking that button there next to the cluster. Okay. We're going to pivot from here. So hopefully folks have gone ahead and downloaded the Compass client. I think there is a link in. I've shown this. We've shown how to white label or IP access this. We've changed the terminology there. And here's our Compass link. So let me go ahead and stick this in the chat. For some folks, last time, some Mac users got a complaint about permissions installing. So just a word to the wise there, that may come up. Where is my chat? Here we go. Where is the chat?
Aaron, if you want to drop it in Slack, I can drop it in the chat if you can't find it. Oh, there we go.
I got it. I just need to leave it up here. Keep it on my other screen. So feel free to go ahead and download Compass. As you will see, it's a nice little logo like this here on my Mac. Disconnect this. And we will show how we get into connected from a cluster. Okay, this guy is now back and running. So again, with Atlas, fairly straightforward. Go ahead and press connect. As you can see, because I've created those private endpoints, it allows me to select a different connection string to connect over those private endpoints. So something to keep in mind if you do go that route. The connection strings do change, obviously. There's a few different methods, but this is pretty important. As you enable those things, you'll also have to update the clients to connect over those connections. We're going to do a standard connection. You shouldn't even see that option without the private connection offered. And then go ahead and hit Mongo Compass. There's a download option here if you don't have it. course I do. Latest and greatest, and it's as simple as copying and pasting this connection string. We'll go ahead and I'll do it from scratch here. And then it allows you to go ahead and modify. I think this one was this one was Aaron. And enter your password. Something we discussed last time. So by default, all users are going to be added into a collection within the cluster called admin. So that's where we're going to store all the usernames and passwords that get created to the database. They don't necessarily have to live there, but by default, that's where we're going to put them. There may be some other reasons why we wouldn't want that, but for now, we'll leave that alone. Oh, and of course, did I fat finger it? Yes, I did. Okay. So I've gone ahead and connected to this cluster. I'm going to actually use a separate cluster here to do some of these demos, but hopefully you're seeing something similar. Don't see any comments, so I think we're in good shape here. Let me show you. I'm going to go to the shared cluster. Do it here. It has all the data sets in it for us. This one. So again, we're going to show you in Compass as well, but a nice piece with Atlas is, with the proper permissions, you can also kind of view the data set here in place. So go ahead and show you that. We're going to use this collection later. If you go and load that sample, you see all these sample underscores will be created in that cluster we just set up. So we're going to be spending time, I think, in this Mflix one, and we're going to do a few other samples. But you should be able to come in, see the collection itself. And Compass has a lot of this same capability, but actually a lot more as well. So we'll dig into the Compass side here in a sec. But let me to that one. And again, as you use Compass, maybe you've got a prod, a dev, and a staging environment. As you create these configurations, you can save them, favorite them, etc. So it's pretty simple and easy to connect to them. And of course, I don't see mine, so let's go ahead and reconnect to shared demo the old-fashioned way. See it one more time. Oops. This guy. This one, I believe, is on. Yes. Great. Okay. So let me get rid of that one. Like I mentioned, the Atlas UI and Compass should, look very similar, obviously, but also show, whatever data sets you've got available to you within the cluster. Again, based on those user permissions and those roles that are available to you. But let's go ahead and dig into clients and customers. Great. And at the same time, I'm going to go ahead and bring up some of the meetup scripts that we've already created here. So you'll see in this Compass, under Compass demo and Compass script under that repo, there's a few utilities. with our command line tool, we often use mgenerate to help build data sets. So let me go ahead and show you what this might look like. So this file here is obviously included as well. What it's defining is really a schema. And you can see here it allows us to set some variables and load some really dummy data in here so that we can interact. Oops, someone's having a hard time seeing. Let's see if I can make this bigger for you. I'll do the same thing on the web here in a minute. Okay. So what we're seeing, for example, we're setting a region. In this case, it's a number from 0 to 1999. So what will happen is this mgenerate utility will read the schema and we'll go create a JSON document using random numbers based on what's put into the schema document. So again, generating a random email, random dates, a gender, male or female, maybe some lat long data, a zip code. And you can see here, this is an embedded document where we've got, arrays and subdocuments, policy types. So this is really like an insurance type of use case where we've got some sort of policy, auto, home, and life in this case. So 3 separate policies in an array, and each one of those sub policies is again a document. So this is highlighting, number one, the flexibility of the document model, but also the utility here that allows us to kind of build these things in place. So I've got this running here. It's just okay. So I went ahead and ran this the command that we saw earlier to create a JSON file with 5,000 records in it. So I'm just going ahead and run it again. Let me make this bigger for you guys. So the point is here. Oops. You can run the same command on your data set or locally and create a data set, and then the Mongo import utility, which is right after it, will allow us to then import that document set into Mongo. So again, a very useful tool for devs, for really anybody working with large data sets. We use it quite a bit internally. In this case, I'm going to make this a little bigger. We use it here internally a lot to help model customers' data, right? So give us an example of what your schema looks like. We can then go ahead and create a sample set of documents. And then in this case, I created 10,000. And then with a simple import command, we can put that into the database that we'd like. So let me go back into Atlas and show you where to pull that command. So get back into my cluster and scroll over to command line tools. And you'll see that there is a sample syntaxed for a Mongo import, which is essentially the same thing as this. So really what we care about is, these host connection strings. And in this case, Mongo import's going to take, it's a 3-node cluster, so it's going to take all 3 nodes, connect to the primary, but then should any kind of switchovers happen, it would stay connected to whichever primary is primary. So we list all 3, and then of course the username and password we created, that JSON file we created, and which cluster we'd like to put this into. So I think I've gone ahead and run that already, but feel free to give that a shot on your own. So clients, customers, in this case, as you can see, I did that 5,000 document entry. It created, again, a fairly dynamic set with random values in it, so that, you know, some of these might not make sense, but some of them might, right? 1975 was a long time ago, but that could be accurate still. And of course, again, you could put bounds on that and generate so that maybe, you know, the data set is more realistic or accurate. Great. Okay. So what we wanted to show here is the capabilities within Compass to go ahead and build out a query, for example. So we'll go ahead and run this. Oh, and it didn't like it, which is fine. Like I mentioned, the data set is dynamic. So in this case, I'm only searching for somebody, a female, who was born between basically January 1st and December 12th, 1990. So let's open this up to 2000. See if we get more hits. They were then looking for people in Utah that have a life insurance and are also a smoker. So it's a pretty, there we go. We found 3. It's a pretty specific query. So what the Compass tool allows us to do, obviously, is run this thing in place. But we can also check on a few different things. So let's go ahead and run this with an explain plan. What this is going to do is really tell us exactly how the database engine found those 3 results. So in this case, you can see we did a collection scan, and we actually examined all 5,000 documents. Now, that's probably not the most efficient way to do it, right? So let's go and look. And sure enough, in this case, we just created this thing. There's only a single index. And by default, Mongo is going to index the ID. So the underscore ID is by default the unique identifier within every collection, and is also set up as an index. But that's the only index. So what we're going to do is create a compound index here. So what did we pick? We picked the state, and that's a text.
Aaron, I just saw this question, but if you're coming from a SQL mindset, is there a good way to map some of the find commands in Mongo?
Yes. So yeah, I can go back to that. It's effectively a query statement. So yeah, let me go back to the syntax in a minute once I finish this. We've got to add a few different more here. What did I say? Date of birth, state, gender, and we added date of birth, state, address, policy type, or is smoker too? Person smoking, and policy type. That's location type, policy address, policy type. There it is. You know, a few different things to point out. Again, because we're in a document model, we'll absolutely get back to the search syntax there. But the beauty of Mongo is we really allow you to index anything. As you can see here, I'm creating a compound index that runs through not only the parent fields or attributes within a collection, but also is, you know, in this case, in the address, reaching down to the subdocument and pulling out an attribute of the subdocument of the address. Same thing with policy. We're going to go ahead and create this. Oops, not that one. Create this. And it's going to go ahead, in this case, because it was only 5,000 documents, it happened pretty quickly. But once it's in place, now let me get back to my query here and hit my find. So you can see it still didn't take a lot of time, but as we do our explain plan, let me not hit all of my gender, date, address, policy, life, and insured smoking. I'm pretty sure we got it. So yes, let me back out of this query. What we're basically doing here, again, this should look familiar in that, it's somewhat JavaScript syntaxed, but this is effectively a find command. And as we walk through, it's going to list the actual field names. Let me go in here. So in this case, gender. And the second kind of list in the attribute will be the value we're looking for. And then, for example, comma, so we're matching on gender and equal to female. And then as well as, so a comma here would be like an and, date of birth. And in this case, we're doing a range, a greater than and a less than. Hopefully you can read that. So $ greater than, $ less than. So 2 arguments here for the date of birth range. A straight match on Utah, and then on these policy types, which is an element match, effectively saying we need a policy type of life and the insured smoking equal to true. Now we can filter, this out. So to make it more simple, maybe we're taking the state requirements and the policy requirements out. In this case, we get 300 documents returned, a much larger data set. The tool allows you to also then kind of nest what a find command supports. So in the case where you want to limit the amount of fields that are being returned by the query, you can use our project field. And in this case, it's really a Boolean. So you put the fields you want with either a 1 or the fields you want to omit with a 0. So let's say for this query, maybe we just want cell maybe one other thing. What do we feel like? Email maybe. Oops. So hopefully you're seeing kind of how the syntax works there. Oops, missed the close run. If we run our find, now we get, by default, you always get the unique identifier, the ID, but we've limited, or we're only projecting in the response, the cell number and email address in this case. Of course, to, for performance reasons, right? To limit the results there. There's a lot more to get your mind around when you're coming from relational. I think we do have a slide. Let me pivot real quick for that question and bring up the slide where there's like a terminology kind of like for like here in one of these. This is kind of terminology. Here we go. So and of course, there's a lot of, I'm going to plug our university here. There's a lot of really good content available from Mongo to kind of go through regardless, we can kind of pull this apart in a lot of different ways. But at a high level, for folks coming off SQL or relational database models, in terms of you probably already heard me using some of this terminology. A database stays a database in our world. But a table is really thought of as a collection, a document collection in ours. And of course, in relational, you get kind of these, B trees, you get these kind of split out parent-child tables with references. What we like to do in Mongo, if we can, is store all the data together that's accessed together. And that really comes down to fetching performance, right? So if I've got a customer object that also has maybe in this example we showed a policy ID, I don't want to store those in 2 separate databases and then have to go fetch them in 2 different places if they're always going to be kind of pulled back together. What we'd rather do is embed that as a subdocument within potentially the customer, or maybe that's vice versa, depending on the use case, and allow for the applications to really access and extract all that information just from pulling that one document as needed. So there's lots of different design methodologies and how we can build out schemas depending on where you're coming from the relational world. Obviously, a lot of people are writing straight to document, and those use cases are much more straightforward. But we'll be happy to kind of dig into some of those use cases at any point as they make sense. Just to continue on, index is obviously an index. We showed how we could create that in Compass. A row or a maps to what we would call a document. Effectively, this, reset this. This would be, an analogous, easy for me to say, to a row. And then a column would be a field or an attribute within a document. We do support the concept of joins. Again, like I said, what we typically like to see is for documents to kind of contain subdocuments that make sense. Mongo supports up to 16 meg in a single document, so that can be a lot of information in a document, depending on the use case. But something we have added is the ability to of course, we call it a $sign lookup, but essentially pull attributes from another collection in a single query. So you can kind of do cross collection querying there. We do have the ability to create materialized view or read-only views on Mongo as well. So that's a pretty common use case, either using an aggregation pipeline, which we're going to jump into in a little bit, or just a standard kind of dollar out, which we would call taking an output of a query or a subset of the documents within a collection and creating another collection from it for potentially read-only type use case or simplified reading.
Aaron, two more questions that have come through. One is, where does the VS Code reside? Did you answer that?
The VS Code. So yes, there was a link. I'll put it back in the chat. I don't know if the chat got wiped, but the repo itself is here. Back in.
And then the other question was, is there any reference material on using Mongo collections with MVC?
MVC. Can you explain MVC, model design?
You're gonna come off mute, Jay.
Yeah. Sure, and maybe the question is kind of like, more complicated than it really needs to be. But like, yeah, in some, like when you're developing some websites, like using, I guess like Java Spring or even PHP, like a lot of times, like in those frameworks, you'll see a lot of the database stuff being like developed first with like models, and then those models map over to like the SQL database using like ORM, object relational mappers. I was just curious about like, how does that work with Mongo?
Yeah, I mean, honestly, that ORM layer oftentimes can be eliminated. Now, there's, depending on where you're coming from, there's scenarios where maybe we're helping to offload the relational database for better read performance, for example. And there's lots of ways to do that mapping. It's not too difficult. I'm going to share again. There's a blog post here on kind of building with patterns. This is a really good one. There's a large number of kind of design patterns we like to think about. In particular with relational, what we will typically do is, again, try to build a model where where it makes sense, create subdocuments from multiple tables, again, where the data allows us to. And there are a lot of third parties that help us kind of manipulate that data. So we have partners that have built some middle layer actually there to help not only define the schema, but also like move the data as well, manipulate the data and move it into Mongo. So depending on, how big the problem is and where you're coming from, there's a few different options there on how we would do the redesign itself or the schema redesign, and or kind of let both systems coexist if need be, by taking a subset of the relational data and making that presentable to the client side to offload it.
Thank you. Yeah, this is great. I'll take a look at it.
Great. Let me get back to this guy. So, I guess back to, since we're hitting on this might be what you see today, right? Where the developers are trying to write to a customer object, an opportunity object, a contact object. And then there's some sort of mapping that has to happen, whether that's an actual ORM layer or not, because of the way that the drivers work, we can actually store those objects as they're intended to be stored, right? So as the object themselves. So the developer doesn't have to even put that ORM kind of dynamic in their head or have that conversation around, okay, but what does this object actually map to in the database? It's literally a one-to-one mapping in these cases where a customer means customer and an opportunity means the opportunity, right? So that, obviously it simplifies the logic for the developers, but also for everyone else supporting the application. And again, with these drivers, and we'll show JavaScript here, we kind of hinted on it a little bit, it allows you to work in that native language with those native objects and literally, just using our find commands where you need to run a query and insert one or insert many where you need to add, for example, directly with those objects in code instead of, refactoring or serializing, deserializing data. All of that is done at the driver level and kind of simplifies really everything for the stack. So it's all about eliminating tech debt there, right? Cool. Okay, we cruising right along here. So let me pop back in. We ran a query. We added an index. I showed what that looked like. Again, very simple. What I'm going to show here quickly, the tool that we built in Atlas that comes kind of out of the box. So back to those query performances. Let me maybe break this out. Yeah, this has been a quiet cluster today. Let me go find a better one. The profiler will actually sit and watch, pre-sales. We'll sit and actually watch all the queries happening on a given cluster and track for anything, finger quotes slow. In this case, really on the order of seconds instead of milliseconds. And where is the query profiler here? Come on. Metrics. Okay. One sec. Let's go back to shared. So really, in production, as you deploy new code, as things change in the cluster, Atlas itself can be, another point. There we go. To help you monitor literally individual queries. So in this case, we see this metrics, this query run on metrics employees ran about 16 seconds long. So it's literally cataloging all those queries that take, like I mentioned, really more than a second are going to show here. And then it's looking over time it will actually make index suggestions to the operator. And now these could be alerts too, right? So I can get an email alert at 10 a.m. that says, hey, we've got 300 queries running that are non-performant. You might want to come in and create an index. And it stack ranks them based on the impact that we believe it'll have by applying the index. And actually allows you to dig into what the query looks like itself, but also with the right admins, create this index in place. So Atlas becomes more proactive than reactive in letting you know if and when, you know, performance is suffering really for any applications and any queries in particular. So this is a very, very important tool. And like I said, we can automate a lot of this where alerts go into a Slack channel or an email or however you want to consume them to help you with that index management. Very, very important. Okay. We talked about the project, and I'm going to, okay, validation is important. Let's touch on that. So back to Compass. Let me see if I can get this guy bigger for you too. We quickly showed, you know, how we could run a query. I showed you what the explain plan and how that can be used to look at query performance in real time. We also have data validation rules that you can build in place. So let me take this one. In this case, we are gonna set and look for in the gender field and only allow for values of male, and again, this is now case sensitive, so lowercase male or uppercase F for female. And so you can see this one passes, but this one with the capital M is failing. So if I make this an M, this should be okay now. There we go. So now we're not rejecting. So, you know, what the power of this is now, as, you know, typically as you're starting to build an application, you maybe aren't worried so much about data validation, but as maybe releases change or as requirements change, we can actually now set rules on a collection that say, no, actually this field has to be this, that, or the other thing. So like I said, in this case, it has to equal male or it has to equal female. Now, what we do if it doesn't is a definition as well. So in this case, by default, it's set to error. What that means is that insert, the update will fail and the application will get an error, or we can just throw a warning in the log that says, you know, this is out of the validation, but we're going to go ahead and update it so that you at least have in a warning log, you can go look at those cases, right? So it's more of a soft failure. But again, very powerful tool here that Compass Unlocks allows you to apply this stuff in place and also test it in place and see visual cues on an individual, on a given data set in terms of what the validation would do to that data set. Okay. I think that's roughly our Compass demo. I'm going to spend some time in VS Code now. So one thing we'd recommend is installing the plugin DB for VS Code. So again, I went to the extensions here in VS Code, search for MongoDB, and it's this MongoDB for VS Code plugin. Once you have it installed, you'll see the pretty Mongo leaf and the ability to create database connections. So much like we did with Compass, it's effectively the same exact connection string you can use here and now connect directly within VS Code to those clusters, get access to, you know, what collections are in there. And then as I've done here, you can even launch a shell. And it will open up a shell in this terminal. So I've got a shell running here. So we're going to use that. I'm going to spend most of my time in here now because this is kind of how I like to work. And again, you can see I've connected to several different clusters. I can keep all those connected. I could, potentially pop between them as needed very easily with a double click now because it's stored my credentials. It becomes a very nice tool to have, of course, as you're toying with code. So let me get back into our shell demo. Okay, so let's see, show databases. And again, this is that same test set that we worked with before. You can see here, I've got a database called JavaScript LA, but in this case, there's nothing really in it, I believe. Or it's very small. Yes, 8 documents. Go ahead and delete it. Okay. So nice piece with the command line utility. So show databases, and our JavaScript LA is gone. But yeah, with the CLI, if I do a use, oops, easy for me to write. Come on, there it goes. In this case, just typing in the use JavaScript LA will actually create that database if it doesn't exist. So now we would see that database. What I'm going to go ahead and do is just insert these items with an insert many into our newly created database. And just to show you what that looks like in Compass. Machine, where are you? Okay. So, okay, we created it. And let's just look at all of them. Oops, DB, sales, my typing. Find, and we'll look for all 8 in which we got them. Perfect. I've gone ahead and changed some of the dates in here. So you may see those old 2014 and 15 dates in the repository. I'll submit this later. I just went and made them more current. So now, if I go ahead and run this find command, looking for everything that happened April of last year, April 4th and 5th of last year, we find a hit on 2. Again, the point here is that our shell really takes and leverages a very familiar framework, hopefully, or languages, as you're familiar with in JavaScript. So the syntax should be very similar. Oops. Oh, I already can define this. Okay. So you can even come in here and create a definition, an object, or a variable definition like it did aggregation. I just complained because I've already created it in my testing earlier. And I can go ahead and run this aggregation as I defined it as aggregation. And I get this nice result of total sale amount. It's listing, of course, the ID with the item variable. So, or the item attribute. So whether it's little, big, or medium, I suppose, and then doing a calculation here. So we're multiplying price times quantity and indicating it here. So pretty simple use case or simple aggregation, but again, CLI is a great place to kind of leverage that. As you may have saw, my Compass does not want to come back. Let me just restart it. We can run that same aggregation in Compass and with a visual queue. So I'm going to go ahead and do that for you. Compass has a few interesting tools, or at least the ability to save aggregations in place so that you can apply them, share them with other people, etc. Get in there. And here's our JavaScript LA. Come on. And here's our data set. Again, 8 documents, very simple data set. But let's go ahead and basically take the same aggregation. Oops. This same aggregation. And it breaks it apart. Blow this up for you. Maybe that's why it filled out on me. We'll go ahead and save it as something. So in this case, we've got a 2-stage aggregation. First, we're looking for a date range, and second, we're running that calculation. So again, the benefit of Compass here is it gives you that kind of visual cue of what's going on with the data set as you run these aggregations in place. The nice piece here is as well is once you've got something working, as you can see, it's like we pointed out, everything's kind of native to JavaScript here, so it should look familiar on the left. But if I need to put this in Python or maybe Java, Compass allows me to kind of make that transition pretty quickly, cut and paste and run. So once you've got this defined properly, it's very easy to share across really any type of application space. Maybe it's C++ or C#. Again, as you saw, I saved this, so I can then kind of come back and access this later should I want to, and or make modifications to it, use it somewhere else, that sort of thing. So pretty effective tool here, and something that we use quite a bit. Great. Okay, let's stay in the shell. So one of the nice pieces, again, let's move in this case to some of that sample data we set up. And hopefully folks are keeping along here. Feel free to slow me down if I'm going too quick. So we moved over to our mflix data. Now let's look for, in this case, we're actually going to define a variable here called flix, and we're looking for everything with an IMDb rating greater than 7. In this case, we're actually, let me change it to, we'll look at 3 different movies here. And what we're going to do is go ahead and run a cursor here and pull back these objects. So that happened pretty quick. Let me kind of back up. And you'll get to see the data set here. So in this case, we ran through and it said we found 3 records based on our limit. Let me go ahead and just limit that to 1 maybe, and we can run through it again. Just see 1. Oops. I'll cut it over again. Doesn't like my recall. There we go. So in this case, now we have 1 just by changing our limit count there, and we've found a great train robbery. And where's the IMDb rating? 7.4. So again, great utility to kind of test code in place, test sample code against a real data set, potentially out of band here, and see what your results are going to be. Pretty simple utility again, but hopefully you can see the power and what it can support. Okay, And then let's go ahead and do another test. In this case, I'm going to call it test JSLA. So let's go ahead and create another database here. And in this case, it's pretty lame data. We're just going to put in a nome and an age. I don't know why it's nome, not name, but we're going to do it. So we're going to insert whatever that is, 10 records. You can see they all come back successful. Let's make sure. Okay, so we've got our data set here. Now we're going to build a quick function that we're going to call it myzip, effectively identify a random zip code between 90,000 and 10,000. And we're going to go ahead and for this loop here, iterate and update each record by adding a zip. So just to quickly and show you how easy it is to work with the data here, it's gone back and called myzip and for each ID or each object or each document within the collection, gone ahead and created a new zip with that random value in it. Here, let me show you the pretty view. Makes it a little bit nicer to read. Puts in some white space for you. And also, again, now we can go ahead and add an area code as well. So we've added a zip. Maybe the next thing to do is, enrich the data with some area code data. Very simple. Again, now we're going to iterate, call my area code, and add it into our document. And there we go. So now we've got some random zip code data in here. Cool. Okay. Hopefully they can see the power of that again. This goes back to, again, the flexibility of the document model. Now imagine adding on validation rules with the flexibility that would give you to kind of manipulate the data set as you need to. And you get kind of the best of both worlds, if you will. So very simple to kind of iterate on the schema itself, make changes to it. But then when you do need to lock it down, those capabilities are absolutely there and ready for you. Good, good. Okay. Now we're gonna, let's see, take a little break out of our code here. Let me get back to our data set. Okay, so we took care, let me go ahead and present. I'll walk through some of the benefits and kind of advanced features of Mongo itself. So of course, like we just showed, it's pretty simple to come and create a cluster. Showed a little bit about how to secure it. We didn't talk a lot about the backup and kind of monitoring, but all those tools are kind of built in. Showed a little bit about the query index and profiler. And we'll touch a little bit more on sync and server later. But Mongo Atlas is truly a database or data layer as a service. We like to think of it as an intelligent data platform. Of course, the heart of it is the MongoDB server. I think a lot of you have probably worked with Mongo database itself, potentially for a long time. Of course, Atlas is kind of the wrapper around that and unlocking a large other set of features. One of the most important being full text search. So this is a true Lucene-based and very powerful search engine that runs on top of Atlas, allowing us to create basically full text index searches across any number. So when we saw how we created an index and a compound index there, really with the full text search, it allows us to potentially index everything in the document if you would like, but also, again, leverage those very advanced Lucene features to also do things like weighting and kind of creating, almost, it's hard to say, but we are seeing lots of cases where we can displace Elasticsearch itself with MongoDB Atlas search. So highly recommend you take a peek at that. We can certainly, do a deep dive. Maybe that's something we can add to the agenda next time and show the capabilities of it. But it's again, a truly powerful search engine there. And then you add on top of that the data lake capabilities. So this allows us to, there's a few aspects. There's auto archiving as well, where we can take and use a time to live index and move data from an active data set or what we would call a working set into maybe more of an archive mode, where you can still query and access that data, but maybe at a different performance than the active working set. But this can also be simple things like an S3 bucket with JSON files in it that we can also access as part of that data lake functionality, or even CSV files, for example. So you can really bring your own data in these use cases, and then leverage the power of Atlas to really query across all of it at the same time.
Aaron, it was just asked, is there a good workflow for syncing data across stage and production clusters? Is CI/CD involved?
Yes, yeah. There's a few different ways. We have a live migrate option, really, where it's a utility that's effectively watching one cluster and using the op log to basically regenerate all changes into another cluster. We do that a lot, really, with our on-prem to Atlas migrations, where we're syncing real time. Is it more of a one-time sync that you're looking for, or something that's dynamic and kind of ongoing?
Yeah, I'm the one who asked the question again. I was just thinking out loud because, a lot of times, like as a developer, you'll be working with, like a local database or something like that. And then later on, it's completely different from stage, or I guess even production. But I guess, so in some use cases, you want to sync changes from like a stage site to a production site, and I'm just thinking about the workflow also involved for like keeping data in sync, because, like if you show something on like a staging site and it's working there, like you want it to be working on the production too, and vice versa, like sync back to stage,
right?
If needed.
Yeah. What I'm showing here, I've just pivoted to Atlas, and I, within the cluster, just hit the backup feature. So this can be enabled, disabled, and there's some different levers on how we do backup. But what I'm going to show you here is really a point in time and store. So this one's set up to be continuous backup. So what that means is, while we'll do snapshots, typically hourly, but it can be daily, whatever it might be. And between those, we'll use our ops log to kind of, again, regenerate any changes in between snapshots. So this allows us to really get to a point in time restore. So you can literally get down to a minute, for example, an hour, minute, and say, I want to restore data from this cluster. Let's just take one. So I'm starting at shared cluster, but where am I putting it, right? So I can actually put this into a separate cluster directly using the Atlas utility. So this is probably the simplest way to do it. But there's obviously other ways to do it, right? You can do the snapshot restore, and maybe that's all you need for your use case, where we know what that data set looks like. Let's take a snapshot, and now we're just going to move that over and do the restore. And that, can take a matter of just minutes, depending on the use case. or that utility of live sync, that Mongo sync capability, online sync, would allow you to connect just with the connection strings, like move a collection from one, or I say update a collection from one cluster to another, in an active way, in an ongoing way.
Like a hook, or I guess, like maybe programmatically being able to do it.
Yep.
That's what you're talking about. Okay.
Exactly.
Yeah, but This is good too. Yeah, just in case, like, you need to go back.
Yeah, this is really useful. A lot of our customers, again, the larger your cluster gets, we haven't really talked about sharding, but the more complexity in the cluster, the harder it is to do these backup restores. Atlas has really automated all of that as well. It makes it very simple.
Okay. And you have resources for that too, right? Like, I guess, what's the best place on the docs?
Yes. That's a good question. So let's do docs. I think there's the live. Let's see if there's a live migrate. Yeah. It's a sharded cluster. I'll send you this one.
Sure.
The Mongo mirror restore. Again, we showed import in the previous example where we're taking a set of JSON documents in a file and importing those. But mirror is really that live sync capability. And of course, restore would take a snapshot from wherever it might be and allow you to store it to another cluster.
Awesome.
Yeah, this live migrate one, we use this all the time for customers coming either from an on-prem or a community version, and they're wanting to get into Atlas. We'll basically set up a maintenance window. We'll get this thing running, and then we'll test both things in place, right? Then eventually turn down the old system.
Thank you.
Absolutely. New problem. Okay. Great question. And this is built out, so we'll just go ahead and present it. We talked about the serverless functions again. So we support a GraphQL function right on Mongo Atlas, so you can really unlock any type of webhooks or REST API, enablement of your data pretty simply. We touched on the drivers. I think there's another slide here that goes through the whole driver list, but like we said, the power of the drivers allows the developers just to work in their objects, right? And then we take care of really manipulating any of that data, storing it in BSON objects or binary JSON as needed, but allowing developers to kind of simplify their mind in terms of the architecture of the data. I'm going to show charts. We didn't get to that last time, so just for some folks to show them something new, I'll quickly touch on charts later. It's basically the way that Atlas unlocks visualizations on top of our data, and you can use those to embed, basically create a link and embed that wherever you'd like. We touched briefly on the connectors. Maybe I'll touch on the BI connector. We have some relational folks here. That one's pretty useful. Of course, Spark and Kafka, Confluent for a sync source type model. So lots of great tools out of the box. We talked about data at the edge. For us means Realm. That can be Realm serverless, meaning triggers, functions, GraphQL, like we mentioned, and unlocking those data sets at the edge, or it can be at the actual database on a mobile device. So Realm runs as a local database, a true offline first database for iOS and Android devices. So with some syncing logic built in the background, again, whole goal is to kind of simplify the tech stack, get developers from writing sync code and network management layer code, and focusing on business logic only. So great product and fairly new to Mongo. Nicely built into the Atlas layer. So we'll jump into that a little bit. And then IoT or embedding. So actually just to plug a use case, 7-Eleven is using us at all their stores, something like 8,200 stores across North America. to not only run on the tablets and but also kind of do inventory control as well. So true kind of like IoT use case, looking at the freezer temperatures and security alarms and everything else going on in a 7-Eleven. Well, we already kind of popped through this. Let me goof down. I showed you the VS code and the connection string there. Oh, this one's useful. Okay, let's take a peek at this. So this is a very simple, and hopefully you guys have all this. This is a very simple way to quickly run up a container running Mongo client. So let me go, I think I've already done it. Yeah, and it's already running. So yeah, there's our guy. Just grab Docker. Oh, am I still running? No, I'm not. Good. Sudo. Execute. Bash, bin bash. Sudo. Typing is really bad tonight. Sorry. There we go. Good. So what we've done here is basically just spin up a quick Docker container running the Mongo client, or basically our CLI tools. So this is going to allow us to basically run those same connection queries that we have here. This is another useful utility is I can copy this guy, copy connection string. I'm going to go Mongo. Oops. Mongo shell. Okay, how did I do it here? Yeah, it does not like. So a few things about the command line. You can see here, there we go. All right, I'm connected. No, I'm not. What did it do?
You have the Mongo command, right? Was that verified? Like, I guess when you install Docker.
Yeah, it is, and it's running Mongo shell. It's just not giving me the cursor back. Starting.
Oh, right. Yeah, there it is. Okay.
One sec. Let me look here. Just did this previously. Okay. Entry point. Yeah. Version. Let's see that. Mongo shell version, yeah, that's right. I don't think it likes my connection string. It's these source admin. Oh, wrong database.
Okay.
Yeah, that's what it was. There we go. Sorry about that, but yeah, so you should be able to use that same connection string. Watch for your document or your database name there, and effectively you get the same terminal capabilities here, but just run through a Docker container. So another useful utility, maybe you're running this somewhere else and want to see it run out of a container. Fairly straightforward. That is all also in, no, that was in the slideware. That was in the slideware only. So, basically all those same commands we ran in the shell and VS code would apply and run fine within this environment as well. Back to a kind of a higher level, one of the things we touched on, of course, is the flexibility of the data model. One thing I didn't say was we also support atomic transactions across multiple documents as well, or multiple collections, I should say, as well, which is a differentiator for us in the NoSQL space. And really what it means is, as you need to make potentially more complicated multiple changes at the application layer, the database kind of reacts and feels a lot more like a relational database than a document database when it comes to being able to submit transactions that are atomic in nature and applied such as kind of an all-in or all-out type model. Another beautiful piece is really our data set capability. So again, geospatial data, we've got our query language is very very flexible on geospatial. We can do a poly type of geoneer or a kind of radius around a point. So very flexible use cases there. We touched on kind of the full text search capabilities. So the ability to really create an index around any text fields and then search through that text. And then, of course, the Atlas search capabilities that we've seen base search just kind of adds on to that. I touched on the right-hand side, I touched briefly on sharding. So for those that aren't familiar, that's our horizontal scaling kind of methodology. So lots of ways we can scale up vertically within an individual cluster. Here, I want to just show that. Let me get back into the cluster config. There's, yeah, this is a good one. And configuration. So as you deploy a cluster, as you look at the cluster tiers, and this one, we can enable auto scaling capabilities vertically. So what this allows is we can both scale up and down, and you can set some kind of guard lines around how high up to scale, and of course, how far down to scale. In this case, I meant 20 maybe, makes more sense. In this case, we're going to be looking at things like CPU, disk utilization, and RAM, and then deciding, once we are over a certain threshold for a certain amount of time, we'll go ahead and start scaling up that cluster, and then vice versa, scaling down that cluster. So this becomes a really simple way for folks to kind of deploy in place. Maybe they're not sure exactly what the uptake is going to be on an individual application. The cluster itself can, automatically scale for you regardless, which is a very, very nice feature. Now, let's say you go beyond what a single cluster can scale. So we have lots of customers working with not only terabytes, but petabytes worth of data. Back to this picture on the right. What we really do there is then now figure out a way to partition or shard those individual clusters. There's lots of ways we can we can shard. We're obviously looking for a key there to shard on, something with high cardinality that allows us to really split that data set up. We're seeing a lot of folks, we have the ability to do basically geo-based sharding. So I'll just plug that a little bit, where based on locality, we can be growing those shards. So, it could be based on region, for example. You can create a single global cluster in some instances where, we're sharding based on the user's location. And that might mean, users in the US stay in the US shard and scale independent from the users in EMEA, for example. Everybody's aware of GDPR and the kind of data security rules that are out there these days. That becomes a very nice feature to kind of allow for compliance for certain applications. That sharding, again, is something that, the Atlas product kind of brings and automates for you. Becomes very easy to deploy and manage that way. And then I guess lastly, the freedom to run anywhere, like we've kind of hit on. Atlas, of course, we've shown some AWS. You probably saw capabilities for GCP and Azure in there as well. But we have lots of customers that are still running in a private cloud or a hybrid cloud environment and totally within bounds. And like I said, lots of customers using it that way. Just kind of beating the relational horse probably a little bit more. You may see some schemas like this out there. And like we talked about, the goal is to get to a more flat structure where we're talking about objects, both at the application layer and in the database layer. We touched on that. Naturally mapping, 20 different binary types, again, for the JSONs we do support. Here is the driver list. So again, simplifying the server or the application code by really unlocking all those data types in the native language. Of course, JavaScript and Node being our favorite here. Good. So Stitch, you'll see it referred to as Realm within the Atlas utility. So let me go ahead and show you that while we're here. So Realm and Stitch can be used interchangeably. You see that in the slides. I should probably actually update that. Let me get this guy still running. Okay, good. Let me get into this one. Okay, I'll show a couple things. Okay, the shared demo. So like we talked about, we do support effectively a serverless type architecture. What we can unlock is really API and whether that be webhooks or REST-based, just straight access to a data set, effectively using GraphQL. So this one's been set up. We've defined some schema. This was effectively that movie set application. So let me go ahead and add in another one. These movies, yeah, movies ID. Go ahead and run it again. Great. So what this allows us to do is effectively take an Atlas cluster, assign some user configurations, and then define a mapping for that data set, and then display that or make it available for a number of things, GraphQL being one of them, or server-side functions and triggers as defined by and to be called by the application later on. So very powerful, again, here, all built within, like I said, in this case, we're calling it Realm. You'll see it be called Stitch. That was the previous name and was rebranded to the Realm app server-side. utilities, but it's very, again, simple to use. Should be very, very familiar for anybody working with GraphQL previously. And then we touched on the charts. I'll go ahead and highlight this. It's something we didn't get into last time. Let's see. So, again, the ability for us to come in, visualize data sets that are living within Atlas, coming in and I don't have viewer access. I only have viewer access here. Let's see if I can edit this. No, I cannot. Let me go back into another one. I think I have access to this one. Yeah, that's better. Okay, so this is that movie data set that came out of the sample data set. So you can see we can come in and create heat maps here based on the geolocation data, in this case, country of origin for the movie. Of course, all your typical bars and charts and circle graphs, but these are directly built off of the collections within our data set here. So IMDb rating was one thing that we were looking at. As you can see here, that's what we're pulling over. Oh, this is actually movie rating, which is under rated, this one here. But like I mentioned, if we wanted to make this something different, it becomes very simple, easy to come make these changes, pull down the data set itself, whether that's CSV or JSON, or embed these graphs within another data set or another web page on a dashboard, whatever it might be. Powerful utility built within the Atlas product itself. Of course, come in and define which data sets are available for those charts. Like we said, in this case, we were looking at the MFlix movies. Of course, the ability to add pipelines in here too, to simplify or manipulate the data in place within the settings. Great. I also wanted to plug another. We have in the university, we do have a, let me show this one. This is a great course for those folks that have been engaged in the university. This is about 6.5 hours. It's probably not quite that much. This is going to run through really a Node.JS setup, and again, more kind of manipulation on that MFlix data set. So now that we've got that set up, it should be very easy to, it might save you an hour or so on this course, but it does a really nice job of walking through async versus synchronous, and a really setting up a Node.js configuration with some labs, some code here. So I'll plug this one as well. Put this one in the chat.
I put them in the chat. I put it in the
chat. Yeah. Thank you. Awesome. Okay, I'll pause. Is there, we've got about 15 minutes. I can spend some time going back through, looking at some of the aggregations. We could spend some more time in the realm side if there's interest there, or perhaps something else, if there are any other questions.
If everyone just wants to put their preference in the chat or come off mute, whatever you guys want to hear more about. We're also happy to give you 15 minutes back in your afternoon, I'm sure, if everyone's.
I Just this is VJ. Like I've been asking questions all night because I feel like it's super awesome. But and I was just really curious about Realm because like maybe I glossed over it before, but it seems like you kind of have like a better solution than AWS in some ways because you can set up all your like serverless functions in there without having to go through an AWS layer. Right?
That's exactly it. Yep.
That's so cool. So like, if I wanted to just create some endpoints, like, do you think like it's pretty straightforward, like to do one, you know, just to try like